Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on reservoir engineering and pressure transient analysis. And today's topic is about deviation skin. Okay, so usually we have a deviated well and we will have angle between the well bore, between the well and the reservoir. And here we have the schematic. You can see this is our well with wellbore radius of RW, and this well is aligned with a degree, all right, against the reservoir. And the degree is right here. The angle is right here, theta, all right? The angle between the well, all right, and the reservoir, okay? Here, as you can see. So this is our well bore. And then this is the horizontal reservoir. And then you have a dashed line perpendicular to the reservoir. All right. And the angle between this well and the dashed line is the angle or deviation angle. Okay. So in this case, we will have skin factor. And we call the skin factor deviation skin. Or you can also call it inclination skin, or skin due to inclination, or skin due to deviation. Okay. And this is the net pay thickness of the reservoir. This is the horizontal permeability, vertical permeability. And this is the direction of the flow, you can see. All right. This arrow shows the radial flow, and the flow at the proximity of the well will be directed like this. Okay. And actually, this alignment, this configuration, and this direction of the flow will improve the productivity. It is sort of enlarging the flow path towards your wellbore. All right. So rather than creating or inducing positive skin, like in the case of formation damage, this deviation effect will give negative skin. All right. Like stimulation. Okay. So if you have deviation well, it will improve your productivity to some degree. Okay, so this is the picture. This is the simplistic idea of skin due to deviation. And this is the plot created by Chincho. All right, so he created a relationship to describe the skin due to deviation, and we have this plot. Okay, and you can see we only have negative skin. All right, we only have negative deviation skin from 0 in this plot to -5. All right, so on the vertical axis, we have deviation skin, all right, negative deviation skin. And on the horizontal axis, we have whole angle, all right. And here we have the net pay thickness of the reservoir, all right, and the permeability ratio between the vertical permeability and horizontal permeability. This is the type curve. And in this topic, in this video, I will show you the calculation, all right, using the Chincho relationship to calculate the skin due to deviation. Okay, so now we go to our case. Yeah, this is our case. So for example, we have a deviated well with deviation angle of 30 degrees, and the reservoir has net pay thickness H of, for example, 100 feet or 500 feet, just for example. And the wellbore radius RW is 0.5 feet with horizontal permeability or KH of 100 millidarcies with vertical permeability or KV of 50 millidarcies. Okay, now we need to calculate the deviation skin. And we can do that by using these formulas. And I will show you how to use these formulas to finally arrive at the deviation skin. Okay, so first we need to calculate the permeability ratio. Here I have KH divided by KV, or you can also use KV divided by KH. Okay, doesn't matter as long as you are consistent. So if I use KH by KV, then 100 divided by 50, it should be 2. Easy, right? And we also have deviation thickness. We will use this formula. Okay. All right. So HD, or dimensionless thickness, is H 500 divided by Wellbore radius 0.5 multiplied by the square root of permeability ratio. And in this formula, the permeability ratio is KH by KV. So in Excel, I will type in SQRT, open, and the number will be 2 here. All right. Okay, I will make it more spacious. Okay, so the dimensional thickness is 1414. And now we need to calculate the pseudo angle. I call it pseudo angle. This is the formula. It will involve inverse tangent. Okay, but you need to be careful. To be consistent, we need to remember that the angle is in degrees. All right. Okay, so first I will calculate the arctangent, and we can do that by using this formula. A10 returns the arctangent of a number in radians, right? In radians in this range. Okay, so this calculation will give us a number in radians. And later on, we need to calculate that radian number to degree. Okay, so first here, the permeability ratio is Kv divided by Kh, or 1 divided by this result. Okay, so I will use SQRT of 1 divided by 2, right? Because this is Kv by Kh, whereas here I have Kh by Kv. Okay, multiplied by the tangent, right? The tangent of this angle. But you need to be careful that here in this calculation, the angle should be converted first to radians. Okay, so I will type in radians. Okay, radians of 30 here. And then I will close the tangent. All right, and then I will close the arctangent. Okay, so please be careful. Radians of 30, and then tangent of this number, and then the arctangent of the whole thing inside. Okay. Okay, so this is the number in radians. So I need to convert this number from radians to degree, and I can do that in Excel by using degrees. Okay, converts radians to degrees. Okay, and then I will open here and close there. Okay, so the pseudo angle is 22.21. Okay, and then I can use these values to finally arrive at deviation skin. Equals, we will use this formula, minus open of pseudo angle divided by 41 close to the power of 2.01. I will be careful here. Minus something to the power of 2.01 can be indefinitive. Okay, so rather than using this form, I will carefully use it. -1 multiplied by these numbers. Okay, so the Excel will calculate them and multiply it with -1. Okay, just to be careful, right? And then I will continue minus this term. Okay, open again, So the angle divided by 56 close to the power of 1.865 multiplied by the logarithmic of this term. And this term is actually dimensionless thickness. Okay, but dimensional thickness divided by 100. So please be careful. Here we have H divided by RW for dimensional thickness multiplied by the square root of permeability ratio. So I will use this one, the logarithmic of the dimensional thickness divided by 100. I will close. All right, and then I will close it once again. Enter. All right, so the deviation skin is minus 0.5. So with this case, with deviation angle of 30 degrees with net pay thickness of 500 feet, wellbore radius, horizontal permeability, and vertical permeability of these numbers, I can sort of stimulate my well, all right, with deviation skin of minus 0.5. Okay, so what if we have higher angle? So for example, 45 degrees, the skin will be bigger in negative numbers. Okay, and then what about 75? Actually, this is the maximum limit of this relationship of this formula. The maximum is 75 degrees. Okay, so maximum we can reach minus 4.7 with the other parameters constant. Of course, you can change, for example, to 100, all right, and make it even thinner, like 50 feet or 30 feet or 10 feet. All right, you can use this formula easily to finally arrive at deviation skin. And lastly, I want to show the consistency between our calculation and the Chincho plot. Okay, so go to the pictures. Here we have, for example, this dark green line. We have a case of 500 feet thick of the reservoir and kV by kh of 0.5. So for example, we will try 75 whole angle. So let's check it out. I will copy this plot. I will put it here. All right, or there. Okay, let me put them down here. Okay. All right. Deviation angle 75, net pay thickness 500, wellbore radius doesn't really matter. Horizontal permeability doesn't really matter. What matters is the ratio. Okay, kV by kh here. So our kV by kh is already 0.5 because we have vertical permeability of 50 and horizontal permeability of 100. Then our kV by kh is 0.5. Okay, and you can see we get deviation skin of minus 4.7. And if you go there, it is consistent because the skin in this plot for our case is also close to minus 4.7. Okay, and we can try another number. For example, here. Okay, so the same line, but with whole angle of 30 degrees, go up. The deviation skin is around 0.5, minus 0.5. So let's change it to 30 degrees and right, minus 0.5. Okay, so if you go from 30 degrees whole angle, go up there, go to the left, close to minus 0.5. Okay, so again, you can use this formula. You can follow this example. to calculate your case and get the deviation factor. All right, so that's all. I hope you enjoyed the video. I hope this video is clear and useful. Thank you so much for watching and see you again in the next Eng-Man videos. Thank you.